So I've got a problem with a car that has a positive acceleration for about 10 seconds. And then after that 10 seconds, it slams on its brakes for 2 seconds. And which gives it a negative acceleration. And what I want to do is I want to be able to determine how fast that car is traveling after hitting those brakes. Okay? So there are two periods in time. There's a period in time in which the car is experiencing a positive acceleration, and there's a period of time where the car is experiencing a negative acceleration. I can't say it's only one period of time with an average acceleration of blah. I mean, you could, but it makes it unnecessarily complicated. Okay? So what I do is I split up my categories into those two periods of time. The positive acceleration and then the negative acceleration. And what I do is I keep track of every bit of information I have. Okay? So first thing I'm going to do is I'm going to list my accelerations. Okay? So in this problem, I had an acceleration of 3 meters per second, and I had a negative 4 meters per second. Okay? So I'm listing my accelerations for the positive and for the negative. Next thing I'm going to do is record the length of time. Okay? Well, this one goes for 10 seconds, and this one goes for 2 seconds. Okay? Next, I'm going to record some other information that's hidden in that problem. And one of the pieces of information is about initial velocity. Now, it doesn't go out and tell you what the initial velocity is, but it does say that the car originally starts at rest. If it starts at rest, or it comes to a stop, you know information. So at rest, it starts at rest, which means it's given a velocity of 0 meters per second. Now, the initial velocity for the negative component, I don't know yet. Okay? And then there is final velocity. What's the final velocity? Okay? Well, after the period of time, the positive acceleration, I don't know what that is. And more importantly, what I'm looking for. That's the answer I'm looking for, that big fat X. Okay? But more than likely, I'm going to have to determine what those two question marks are before I can solve for that X. Okay? So now I'm going to break up the problem. I know acceleration, I know time, I know initial velocity, but I don't know final velocity. I can find that. Okay? So I can say V final is equal to the initial plus the acceleration times the time. Okay? So the initial velocity is 0 meters per second. The acceleration for this period is 3 meters per second, and the time is 10 seconds. Okay? This term is not important. My seconds cancel out with one of those seconds, and I'm left with 3 times 10. I'm left with 30 meters per second. So after 10 seconds, the car is traveling at 30 meters per second. That's the final velocity. I'll write it in pink. It's the final velocity for the positive acceleration. Okay? But it's also something else. It's the initial velocity for the negative acceleration. After those 10 seconds, I slam on the brakes. How fast am I traveling when I slam on my brakes? 30 meters per second. Okay? So it's actually here, too. Okay? Now, I'm trying to fill out that bottom column. I know the exact same things. I know the acceleration, I know the time, I know the initial velocity, and now I'm going to solve for x. Okay, and I'm just going to wipe out this row. Okay? dry that off really quick. Okay, so the initial velocity, 30 meters per second. The acceleration is -4 meters per second per second. The amount of time in which it experiences that acceleration is 2 seconds. What is my final velocity? Okay, so -4 times 2 is going to give me -8. One of those seconds is going to cancel. And now I'm left with 30 meters per second minus 8 meters per second will give me my final velocity. So my final velocity is 22 meters per second. Okay? So after a total of 12 seconds, with 10 seconds of positive acceleration and 2 seconds of negative acceleration, my car is traveling at 22 meters per second. Cool?